This will be inverse trig differentiation. But before we get into the differentiation part, I always like to cover this a little bit because most of you guys obviously have skipped calc or skipped pre-calc or skipped enriched pre-calc, what we used to have everybody take, and you would have studied this in depth. One thing you probably don't see much ever is something called arc sine. Okay, there are different variations. Back in the days, it used to be ARC capital. Okay, that would mean the principal arc sine, the principal inverse sine, because there's actually 2 times at which the sine of an angle equals -1/2. Okay. In general, though, AP uses a lowercase arc, and that is good enough. Now, here's the deal, guys. Arc sine is the exact same thing as sine inverse. It used to be called arc sine back in the days, would be the inverse trig function, the inverse of the sine function, the opposite of the sine function. Part of the reason why it was like that because of the typeset and everything, and then we got better and we put a little -1 up there, the inverse function they'd call it. Okay. One thing we have to remember is that the arc sine or the sine inverse is an angle measurement. Okay. The arc sine or sine inverse, the answer to that problem is an angle measurement. Okay? And so we could say, if we write this differently, sine of an angle equals -1/2. And this is how I think about these problems. Which angle gives me a side ratio of -1/2? Okay? And there's 2 times this happens. And a lot of times, I think about this visually. I like to think about it on the graph. Okay, sine would be what? -1/2. Okay, which quadrant is sine negative in anyways? 3 and 4. Here and here is negative, right? Because the heights would be negative. Okay, so I would think about it right here or right here. But when you guys took geometry, you guys did the inverse sine function, right? And you guys recalled that inverse sine is only in quadrant 1 and 4. Okay. So our triangles will be only in these 2 quadrants. Okay. We can go on and on and on about why it would be over here also, which would, if we were taking pre-calc, we'd want to return these 2 answers. But we want the principal inverse sine or the principal arc sine, which means the only one. So it means the 1 and 1 and 4. Okay. So because we're only here and here, we can't pass the y-axis for our angle measurements. So we'd have positive to 90 or negative to 90. So it'll be plus or minus 90. Okay. That would be our interval. Or from -90 to +90, or -π/2 to +π/2. Okay, so what angle measurement right here gives us the y value -1/2, or the side ratio -1/2. Say again? No, what is the angle measurement? What's the angle measurement that gives us a sine ratio -1/2? What? 30? How about -30? Positive 30 be up here. You good with 30? Let's go radians. But it's okay if you think about it in degrees and convert it to radians, though. What do you got? 30, you think? This angle right here? Yeah? So it'll be -30 degrees or -π/6. Let's move on. Which angle gives us a cosine ratio of 0? And again, arc cosine is the exact same thing as cosine inverse. And again, these both equal theta. They represent this situation, cosine of theta equals 0. When does cosine equal 0? That's what you got to think about. Remember, cosine from back in the days in geometry should be in quadrants 1 and 2. So over here, you would have negative pi over 2 to positive pi over 2 as your domain. Here, you'd have 0 to pi as your domain for cosine. Okay, also, which ordered pair gives us a y value or an x value of 0? Pi over 2, yeah. So theta equals pi over 2. Or arc cosine of 0 equals pi over 2. Now again, in pre-calc, you spent a lot of time on this. Okay, arc tangent is the same thing as tangent inverse. In the AP test, they're going to say arc tangent, not tangent inverse. Tangent's usually the difficult one. Okay, remember tangent, the answers would be in this quadrant or this quadrant. 1 and 4 would be the same as sine. So arc tangent, it's always going to be root 3 or root 3 over 3, right? For those two crazy ones, it's going to be 0, undefined, 1, root 3 over 3. So since it's root 3, it's either going to be this one or it's going to be this one. It's either going to be pi over 6 or pi over 3, right? It's positive, so it's going to be in quadrant 1, right? And you can think about this. Okay, root 3 or root 3 over 3. Which number is bigger, root 3 or root 3 over 3? Root 3 is bigger, right? Okay. How do you get a bigger number? Because tangent, sine over cosine. Taking a small number divided by a big number, or a big number divided by a small number? Big divided by small, so it's going to be right here. So pi over 3 would be your answer. How about this? Probably not geometry, probably not enriched geometry, maybe, hopefully. We would have solved something like this in pre-calc. Couple different ways you can solve this problem. Number one, or way number one, well, this is arc tangent, which means tangent inverse. We have an x in the argument of the tangent inverse function or the arc tangent function, and this equals an angle measurement. This is pi over 4, right? One way to do this problem is to take the tangent of both sides, which is the opposite of arc tangent function, right? Or just convert to a tangent function, because tangent of pi over 4 equals 2x minus 3. What's the tangent of pi over 4? 1. 1 equals 2x minus 3. And hello, easy algebra. Still make a mistake now. X equals 2. Cool? Okay, that's one way to do it. That's probably the way I would do it. How about these problems? If you took pre-calc, probably remember these. If you didn't take pre-calc, welcome. How many of these are we going to see? Probably not many, but we need to know just randomly how to find some stuff. All right, cosine inverse. They could have said arc cosine, so just remember that. They probably would have said arc cosine on the AP test. Arc cosine of negative 1 over 3. Well, a side ratio negative 1 over 3 We know that's not a exact angle, is it? I don't think so. But we need to figure out the sides so we can find the tangent of that angle situation. Okay, cosine is in quadrant 1 or 2. And it's negative. So that means we're in quadrant 2. Again, this means cosine of the angle equals negative 1 over 3. Cosine is adjacent over hypotenuse. That means the adjacent has to be negative 1. The hypotenuse has to be 3. So now we need to find the tangent of this situation. Well, the tangent, we need opposite and adjacent. Well, use Pythagorean theorem, find this third side. 3 squared minus 1 squared equals, we'll call it y squared, because it'd be the height. So 9 minus 1 would be 8. And then square root. Now, usually we would say plus or minus square root, but this is the positive direction for y, correct? And then we can say 2 root 2 if we simplify root 8. 4 times 2, square root of 4 is 2. 2 root 2. Okay, what is the tangent of this triangle that we created using cosine inverse of 1 over negative 3? Well, tangent would be opposite over hypotenuse, or opposite over adjacent, my bad. So then that would be 2 root 2 over negative 1, which is just negative 2 root 2. I promise this is the last one before we get into the derivative part. Okay, answer each of the following. Given y equals arc sine of x. Okay, arc sine might be a new term for us today, but we got to think about it. Okay, we know what sine inverse is. Where 0y and pi over 2, so that means we're in between 0 and pi over 2. Find cosine of that angle. Okay, why is it this way? Well, guys, think about this for a second. Sine of y equals x, right? If we thought it, think about it as the opposite function. Okay, that's why they're saying y. Y stands for the angle. It's really weird, I know. Okay, well, if sine of y equals x, that's like x over 1, right? Because sine is opposite of hypotenuse. That means we're in quadrant 1. We have a triangle whose opposite is x and hypotenuse is 1. Y stands for the angle. Because it's sine of y. Or I already told you guys that arc sine is an angle measurement. That means y is the angle. But Mr. Bonley, isn't y also the height? Yeah, it's really confusing. Isn't x the width? Yeah, but they chose to use x as the side marking. So it's really annoying. I understand that. Okay? We got to find cosine of this angle. Well, that means we need this side length, right? We need this adjacent side. Well, what is it? Use the Pythagorean theorem. 1 squared equals x squared minus this squared, right? Or, because you've seen this quite a bit, let's see, we go square root of 1 squared minus x squared equals this side right here, equals adjacent, which would be square root of 1 minus x squared. So if we were to find cosine of y then is equal to adjacent over hypotenuse, just square root of 1 minus x squared. Over 1, obviously, but we don't need to write that. If we had to do this other problem, we'd say secant of y equals x. Secant, the 1 over cosine. That means it'd be hypotenuse over adjacent. X is the hypotenuse. 1 is the adjacent this time. And then find the other side. Again, confusing part about these problems is y is the angle, x is the side ratio. or a side measurement. It's goofy. All right, let's get past the difficult stuff and get into the calculus. Here we go. Here are the derivatives of the 6 inverse trig functions. Congratulations, you have now learned every derivative. You have now been shown, some of us haven't learned them all, we have now been shown all of the derivatives. And fun fact, on page 378 of your textbook, there is a table, a nice tan table, or I should say tan box, that has all like 27 derivatives we've worked on all year long. Has all of them. Where is that at? 378. "24 derivative rules we've learned. Okay, so let's just find some derivatives. Start off with some light work, the derivative of arc sine 2x. Okay, arc sine, that's just the inverse trig function. We have a formula for this one. The derivative of arc sine, that would be what? U prime over the square root of 1 minus u squared, right? U is 2x. Okay, so u is the argument of the arc sine function. Okay, what is u prime? That's 2. Square root of 1 minus u squared. What is u? That's 2x. 2x, quantity squared. Big mistake people make is the simplification of this, guys. The calculus is actually pretty easy on these. As long as you know this formula. Really easy. The simplification people mess up. 2 over square root of 1 minus, 2 squared x squared, right? So 4x squared. There we go. We're done. Sometimes they simplify, sometimes they don't. Be extremely careful, because I guarantee you they will have this answer as one of the choices. That's where people make the big mistakes. Okay, so don't do that. Okay, arctangent. Arctangent is one of the ones that's probably going to be on there. U prime over 1 plus u squared. Why? Because this one's a little bit easier. Okay, in this case, u is 3x. What is u prime? That's just 3. 1 plus u squared. 3x, quantity squared. After you write it out with just your substitutions, then simplify. 3 over 1 plus, use your power rules. 3 squared, x squared, 9x squared. See that the derivatives are much easier than just finding angle measurements, isn't it? Way easier. Okay, part C. Okay, again, arctangent, the derivative would be u prime over 1 plus u squared. We just got to memorize that. You have got to know it. Memorize it for 3 months, guys. After that, you look at tables. Or if you're taking CALC 2, you have to memorize it for the AP test also. But you'll use it and you'll review it throughout the year. Okay, u is the square root of x. Well, sometimes scratch paper real quick helps a lot. Okay, so the derivative of x to the 1/2, 1/2 x to negative 1/2, which would be 1 over 2 root x, right? Okay, so u prime is 1 over 2 root x over 1 plus square root x squared. Okay, let's see here. This is a complex fraction. This is definitely not going to be an answer choice. So 1 over 2 root x times the reciprocal of this, right? 1 over 1 plus, what's the square root of x quantity squared? Absolute value x. Okay, it is normally just x, right? They've taught you guys just x, algebra 1, algebra 2 probably, but it is absolute value x. We talked about that at the beginning of the year, right? So keep in mind that sometimes, just note, they might not have the absolute value there. They might have said, well, x is positive. Well, if x is positive, it doesn't matter then, right? Okay. All right, so then simplify 1 over 2 root x times 1 plus absolute value x. And then what are they going to do? Just make the function look scarier. That's all they're going to do. Okay, they have an arc secant function with e to the 2x in it. All right, that means our e is the argument of the arc, our u is the argument of the arc secant function. So u equals e to the 2x, so our inner function. Derivative of the inner function would be e to the 2x times 2. You have to use a chain rule on that one. Man, what was arc secant? I better write that down first. U prime over, I think it's like absolute value u plus some garbage. U squared minus 1. So we'd have absolute value e to the 2x power times the square root of u squared e to 2x squared minus 1. And obviously, guys, on your patterns in your table, there's definite observable patterns. Okay, these two are the same, cosine's negative. These two are the same, guess what? Cotangent's negative. These two are the same, cosecant's negative. So they're the same. All the ones that start with C are negative. Okay, so keep that in mind. That'll help you with your memorization. Okay, e to the 2x power. What do we know about e to the 2x? That's an exponential function. It just grows quicker, right? Is it ever negative? Don't need absolute values, and so then we can cancel these, okay? Because you guys would be finding this derivative, and you'll see none of these, and you're like, oh, that's the answer. No, there's ways to simplify this. Okay, so we'll have 2 over, now the square root, e to the 2x power quantity squared, power to a power rule, multiply the powers, e to the 4x minus 1. How many more problems left? 3? Nope, 1. There we go. This one. Typically, you'll see a problem like this on the AP test and multiple choice. You'll have something like this. You look at it at first, like, oh, that's gross. Okay, but then break it apart into its individual components, individual terms. It says differentiate and simplify. We understand this. They're going to simplify all the time, probably. So we need y prime. Well, y is in terms of 2 terms. One of them is an inverse trig function, or arc sine. The other one, a sneaky product. So you got to be careful. Okay? So let's start off. Y prime equals the derivative of arc sine of x. Ooh, what was derivative of arc sine? That's u prime over square root of, is that 1 minus u squared? I believe so. Okay, u is just x. Okay, what's the derivative of x? 1, that's nice. Square root 1 minus x squared, because u is x. Plus, now this is where things get a little interesting. There's a product rule. Okay, first is x times derivative of second. If you need to, scratch paper real quick. I know that's 1 plus x squared to the 1/2 power, right? So I'm finding the derivative of this part of the product. Oh, good catch. There we go. Okay, find the derivative. 1/2 times 1 minus x squared to the negative 1/2 power times 2x, derivative of the inner function. Negative 2x, actually. There we go. Plus second times derivative of first, 1. Okay, let's go through and simplify this. Well, in the simplification process, the math gods have told us no negative powers, right? They also told us to simplify top and bottom. So this 2 will cancel this negative 2. Be careful. You'll miss that negative every once in a while if you cross it off like that. So it looks like we have, what, negative x squared in the numerator then? And then in the denominator, we have the square root of 1 minus x squared plus square root of 1 minus x squared. Well, we have 3 terms. Pretty sure the answer is going to be in 1 term. And why do we want 1 fraction? Why? Well, they might say, okay, find the critical numbers. Find the local maxes or mins of this situation. Well, it's a lot easier if you have 1 term. Common denominator is 1 minus x squared. Okay, we have 1 minus x squared. Square root of 1 minus x squared times square root of 1 minus x squared. Well, that's 1 minus x squared. Keep going. That'd be 1 plus 1 is 2 minus 2x squared over square root of 1 minus x squared. Definitely factor a 2 out. 1 minus x squared, square root of 1 minus x squared. They are not going to have this answer choice. Because this is 1 minus x squared to the 1/2 power, right? This is 1 minus x squared to the 1 power. They're definitely going to subtract these powers and bring it up, which is then equal to 2 square root of 1 minus x squared. They will definitely have this answer listed, not any of these others. Okay, so make sure that we can simplify our choices, do a little bit of algebraic manipulation, and get our answer.